So in this video I'll be talking about an important concept, so in my previous videos I spoke about performing interval estimation, and we spoke about three different interval estimations: the confidence interval, prediction interval, and the tolerance interval. And for confidence interval, I mentioned about this formula, and how the distribution along with the standard error are used to determine the confidence interval. So one thing that we didn't speak about is that both the t value from the t distribution as well as the standard error are dependent on the number of samples required. So depending on the number of samples that you have, your confidence interval can actually change. So to let's see how actually the sample size affects the precision of interval estimation. So from this equation you can get the measured error or the interval for the confidence interval, which is the t value into the standard error. So you can kind of rearrange this equation, and you'll see that n is actually dependent on the t value, the standard error, on the standard deviation, as well as the interval. So now one thing you can do here is, usually the t value is not known unless you know the sample size. So if you assume that your sample size is large, you can actually replace your t value with z value, and z value is nothing but the value from the normal distribution curve. And in this case, if you assume your alpha to be 0.95, or in other words, if you are trying to determine a 95% confidence interval, then z of 0.95 would be around 1.96. This is something that can be calculated. And another thing that you won't know is, unless you have your sample set, is the standard deviation. And from your prior experience, like in case you have a reasonable estimate for the standard deviation of the population, you can actually replace s by sigma. So now with this particular equation, depending on the precision that is required, you can actually determine the sample size that is required for doing the interval estimation. So this, although I showed all the equations in this video, you can actually use a inbuilt calculator in JMP in order to determine the sample size depending on your the precision that is needed. So let me quickly switch over to JMP. So here you can, from the help menu, you can go to sample data, and in the help menu you can open calculators, and you can open the sample size for confidence interval. So here you can choose the parameter of interest. So here we are interested in interval estimation for the means. So here I'm going to leave the mean default and say OK. So this is the calculator that shows up. So here so there are three different values that are required in order to determine the sample size. So the confidence level, as I mentioned before, here the confidence level that we are using is 0.95, and then a reasonable estimate of your population standard deviation. So let's assume the standard deviation is 20, and let's say your margin of error, or that is the half width, full width, half mix, the half width of your confidence interval, let's say is 10. Once you enter these three values, and if you press enter, you can see that the calculated number of samples that would be needed to get a confidence interval, I mean get a confidence interval with this uh, with this precision is around 16. Now let's see how the number of samples vary depending on these three, chaining these three values. So let's say you are interested in a 0.9 or 0.99 or 99% confidence interval. So you can see that if the confidence level increases, the number of samples required to estimate the interval with this precision is increased from 16 to 27. So now let me put it back to 0.95. Now let's say our confidence interval, the standard deviation actually decreases. So now you can see that if the standard deviation decreases, actually the number of samples required actually decreases. Now let me put it back to 20 again. Now let's say your margin of error actually decreases. So now you can see that as the margin of error decreased, uh, or that means your precision that you're looking for decreased. So in order to determine your interval with more precision, you will need more number of samples. And also, as I mentioned earlier, if you increase your confidence level, again, you will need a lot more number of samples. So all this actually translates into what we saw in this equation earlier. You can kind of see that the sample size is directly proportional to the square of standard deviation. So if and also is inversely proportional to the interval, the square of the interval that you are trying to estimate, or the precision. So yeah, you can always use this inbuilt calculator in order to determine the sample size. And always it is a good idea to if you have the rough estimate of the standard deviation, it's always a good idea to determine uh, the rough number of sample data points that you require before conducting the experiment, so that you can make interval estimation with the precision required.